Hi, I'm Kelly Wong, and this is Physics 2, Lab 2, Lines of Charge. So as an overview, I'll be going over the experiment background and purpose, some experimental results from Lab 1, and finally the computational glow script model from this lab. The important conceptual principles that we'll have to remember are Coulomb's law, Newton's second and third laws, and the principle of superposition, which tells us that we can calculate the electric field for individual point charges and add them up to find the total net electric field. So similar to Lab 1, we're still using charge tapes. We're simply using a different method of calculating the electric force and charge on the tapes. Specifically, we're using superposition, where I'll be dividing this tape into segments with a point charge for each segment, and then adding them up to find the total net electric field. And the purpose of this is to obtain a more accurate estimate of Q and magnitude of the electric force. So some assumptions that we'll have to make for this experiment are ignoring the air resistance on a moving object, and treating this tape like it's uniformly distributed charge over the entire length. And this is very important because we are going to be summing up these segments and treating them like line charges rather than just a single point charge for the tape. And we'll also have to assume that each segment will have the same point charge and can be summed to find the total charge of the tape. So some experimental results from Lab 1 shows us the tape length to be 0.203 meters, mass is 0.0002 kilograms, the distance between tapes that were floating were 0.033 meters, the magnitude of the gravitational force was found to be 1.962 times 10 to the negative 3 newtons, the charge on tape B was found to be 1.5 times 10 to the negative 8 coulombs, and finally the magnitude of the electric force, which was 5.38 times 10 to the negative 4th newtons. And so we're actually going to be using these experimental results for our glow script for this lab, specifically the Q that was found, which was 1.5 times 10 to the negative 8 coulombs. And so once I plug that into a glow script code, it returned this model, which shows us the magnitude of the gravitational force, which is given by this green arrow, as well as the one for electric force, which is the blue arrow. So clearly the magnitudes are pretty different, and so we can assume that the previous Q that was determined from Lab 1 is pretty inaccurate when we're looking at the charge of the U tape. And so again, the experimental purpose for Lab 2 was to kind of create a more accurate Q estimate, and that was found by superposition. And this is depicted in the glow script code on the left, where after dividing the tape into 100 segments, I was able to iterate through each of these segments and finding the electric field for each, and then again summing them up to find the total net electric field. And after trying out different Qs, I found one to be 2.9423 times 10 to the negative 8 coulombs, and that created a very accurate estimate for the magnitude of the electric force, as shown in the glow script model on the right. And so both magnitudes of the electric force and gravitational force were found to be around 1.962 times 10 to the negative 3 newtons. And as we know from Newton's third law, this is pretty accurate because these forces should be equal and opposite. And so we can answer these questions about modeling using a point charge versus a line charge. And so with the point charge model, we found that Q was 1.54 times 10 to the negative 8 coulombs, and the line charge gave us Q equals 2.94 times 10 to the negative 8 coulombs. And so these values are pretty different, and these estimates differ because the methods of obtaining them are different. But the line charge model is ultimately more accurate because it's going to sum up these individual electric fields to find the total net electric field, which is what we actually do in real life.